Hey everyone, this is Teacher Alan, streaming again live from online headquarters. As usual, I'm here to verify my statement of telling you that the ministry made science subjects the simplest. As we agreed, we are here to go through an item with the proposed responses, which are not final responses, but editable. We have an item again from chemistry here. I want us to go through. Going through it, which is a simple one, I want us to clarify about something. And the item is about detergents, and it goes. As Jennifer and Janet were moving back home on a rainy day, a car splashed very dirty water onto their white stockings. On reaching home, Jennifer used the product R with spring water, though the stockings remained with dirt spots even on several cleansing. Janet used product Q with the spring water to clean, and the dirt was removed in a single rinse. This left Jennifer confused and would like to know more about the products. K6. As a chemistry learner, explain the category of the product each of the two girls used. Part B, describe how the products work. C, explain the challenges associated with long-term use of such products. And E, evaluate the products. So the item is about detergents. So we have two people. We have Jenny and Janet. This one used detergent R, this one used the Q. They all used the same water, spring water, to clean their stockings, their white stockings. To remind ourselves, they are cleaning the stockings that were dirtied by a dirty water that was splashed by a car. On cleaning the white stockings, R did not thoroughly clean the stockings. They remained with dirty spots. And then for Q, cleaned effectively. In a single rinse, the stockings look clean. So this is an item about detergents, and they want us to help Jennifer understand the products better by part A, explaining the categories each of these two people used. So R is a soapy detergent. So the product R is a soapy detergent. Why do we say like that? Whenever you are responding to this item of detergents, look for which detergent doesn't clean effectively with a certain type of water, and that is usually hard water. We very well know that spring water, rainwater, they are usually hard water sources. The springs and the rain, they are hard water sources. So you look for the product that does not clean thoroughly, that is wastes the detergent, that is more wasted in the cleaning process, that takes long to make foam or to dissolve in water that is considered to be hard. So the one that does one of those three, taking long to dissolve in water to make foam or lather, the one that wastes when used during cleaning, or the one that does not clean effectively with hard water is the soap detergent. The one that cleans effectively or dissolves easily to form lather, even with hard water, or the one that is not wasted, that is required in low amounts than the other, is the one that is a soapless detergent. So basing on the scenario, Jennifer cleaned the stockings, but they remained with the dirty spots, even with several rinsing, meaning that product R is a soap detergent. So R is a soap detergent. Why? Since it did not clean, actually, it did not clean to remove all the dirt with hard spring water. What I wanted to clarify about in this item are the examples. You people always give brand names. Oh, White Star, Jama, Mukwano, Bulu. Those are brand names. They are specific names given to these soap detergents. They depend on the type of a carboxylic or fatty acid used. We know this carboxylic acid. If a fatty acid used is oleic acid, the soap will be named after it. If the fatty acid used is palmitic acid, the soap detergent will be named after it. If it is stearic acid, still the detergent will be named after it. And remember, we said these soap detergents are long chain carboxylic acid, sodium salts. So the common examples we have for soap detergents, we have the likes of sodium stellate, the likes of potassium stellate, we have the sodium olet, or sodium or potassium olet, the sodium or potassium palmitate, these are the examples we give. They are the examples we commonly have as soap detergents commonly used. For non-soap, from Q, being that the Q cleaned effectively, even in a single rinse with the hard spring water, implies that the Q is a soapless detergent. Remember, for categories, they mark the category, the reason for that choice of a category, and then the example. Since it cleaned uh, to remove the dirt in a single lens with the hard spring water. The examples we said we give a category, the reason why you made it the choice, and the example. So the examples we have, the common examples for soapless detergents, we have the sodium lauryl sulfate. We have the likes of the ammonium lauryl sulfate. Examples of soapless detergents, the likes of linear alkyl benzene sulfonic acid. We have the likes of sodium lauryl sulfate. All these ones are examples of soapless detergents. Note the Omo. The Omo are brand names of one of these, basing on the product, the company's choice. You may find that Omo is sodium lauryl sulfate. Omo may be linear alkyl benzene sulfonic acid. Or sometimes they may call this one linear alkyl benzene sulfonate. That is the common name they usually use. These are some of the examples. The ammonium lauryl sulfate. These are the common examples of soapless detergents. Please note the brand names. When they ask for examples of soap detergents, we have the likes of the sodium stearate, basing on the carboxylic acid from which it was derived, and also basing on the salt used. Was it potassium hydroxide or sodium hydroxide? If they use the stearate as the carboxylic acid reacted with sodium hydroxide, the soap detergent formed will be sodium stearate. Being that the carboxylic acid was stearic acid and the salt was, or the base was sodium hydroxide. It depends on the base used and the carboxylic acid. And remember, even these ones are sodium or ammonium salts of long chain alkyl benzene sulfonic acid salts. And they are named after that. I think we are talking. Let's change the examples we give, please. Part B, they're asking us about the detergents work, how the soap and soapless detergents work. So this is the action of detergents. We all know that detergents work by lowering the surface tension of water. That's why we call them surfactants. They are able to do this because they contain the two portions. We know that the detergents are made of the soap, the hydrophobic and the hydrophilic portions, the head and the tail. So the detergents the soap detergents contain the hydrophilic head, and the hydrophobic tail. Members, these words should not scare you. The word hydro means water. The word philic, it is a scientific word that means love. So the soap contains a portion which loves water. We always, and this part is the head. We always hear of the word phobia. I'm hyperphobic, meaning you fear heights. I'm dysphobic, you fear that's something you're talking of. So this word phobic means fear. And the word hydro, we've been using this word since primary, hydroelectricity power, meaning it is power, electricity generated from water. So this word stands for water. So the hydrophobic end of this soap molecule or a detergent molecule hates water. Fear or hating. Your phobia is what you hate, what you fear most. So the soap contains two portions. The hydrophobic tail and the hydrophilic head. And during washing, the hydrophobic or the hydrophilic head dissolves in water. Since it is water loving, it dissolves in water, and once it dissolves in water, it forms the lather we see. It is dirt hating. It hates dirt. That's why the dirt, once the dirt accumulates in water, the foam or the lather disappears. Because what forms it hates dirt. And then the hydrophobic tail attaches to the dirt actually dissolves and dissolves the oily layer that attaches the dirt to a cloth, actually to a cloth, which now which are the stockings, and it attaches on the dirt. So what the hydrophobic tail, what it does, for it being organic, it will dissolve the layer of oil, the oily layer that attaches the dirt to the cloth, which cloth now is, they are the stockings, will dissolve that oil or fat layer, and then it will attach to the cloth, to the dirt that is in the cloth. And once there, on agitation, repeated agitation of the cloth in water, the dirt is broken down to tiny droplets, which are removed from the cloth. Remember, the dirt particles are now broken down. They are exposed. What exposed them? The dirt particles are exposed by the hydrophobic end that dissolved the layer of oil or fat that was attaching it to the fabric or the cloth, which cloth is the stockings now. And the agitation is helping us to break down the dirt molecules to tiny droplets, which can easily be removed from the cloth by rinsing. And basically, this is how a detergent works. We have to understand these concepts better. Don't cram, understand. Part C, is all about the side effects of long-time use of a detergent. One, we know that these detergents are made of chemicals. So these chemicals, once in contact with the skin, most of these chemicals are looking at acids. We hear of sodium hydroxide. The sodium hydroxide is corrosive. Once in contact with the skin, it corrodes the skin, it burns it. So the chemicals in the detergents burn skin. Actually, they don't burn, but they cause skin burns. And this is the danger or the challenge we are talking of. What does this result into? It results into wounds. So this one becomes the effect And when one gets wounds, what happens? What will be the impact? Hence, departing pain to the user. So you give a point, explain it well, and you still give a mitigation. How do we mitigate this problem, this challenge? It is mitigated by washing the hands with plenty of clean water after using the detergent. So you give a point, you give the effect, the challenge we are talking of, the effect of the challenge, and then the impact, the overall outcome of the challenge mentioned. And then the mitigation as well. So talk about others. Once the chemicals are in contact with the eyes, what will happen? They will damage the cells of the eye, and so explain a point well. These soap-less detergents contain phosphates. Once in contact, whereas these phosphates are disposed or exposed to water, they promote or stimulate growth of the algae on the surface of the water. And once that happens, the algae obstructs the light and entry of air into the water, hindering survival of organisms that are surviving in deeper layers of the water. So give a point and explain it well. For evaluation, evaluation is simply giving similarities and differences of the products. This time they have brought us about detergents. Next time the evaluation may be on something else. Evaluate something is to give the similarities and the differences if there are two or more than two. And I'm very sure we have enough information about the similarities and differences. They are all soluble in soft water or effective cleaners in soft water. They are all sodium salts. They are all surfactants. For the differences, we know them. For the soapy detergents and the soapless, we had these ones are biodegradable. These ones are non-biodegradable. For these ones are majorly synthesized from most of the ingredients are natural. For these ones, they mostly use synthetic ingredients. These ones form scum with hard water. These ones do not form scum with hard water. For the soapy detergents, take long to dissolve even in hard water, in soft water. These ones dissolve readily if in all forms of water. These ones are sodium salts of long chain carboxylic acids. For these ones are sodium salts of long chain alkyl benzene sulfonic acid. So there are many differences we can mention, but give a difference and talk about it. Remember, we are not here to give you answers, but to propose to you sample responses to sample items. I'm to online. Don't forget to like. Don't forget to comment. Actually, in the comments, put for me the similarities and differences in the comment section. Let me have the similarities and the differences in your comment sections. Share with your friends so that they can know more about them. Share even about these other responses. I don't think I've given it all. You may also have your direction so long as you are on track. Don't forget to share the videos. To invite even others to watch. I'm to Online and I'm Teacher Alan.